Hey guys, welcome back to my channel. Leo Amy here. So let's continue with the three challenges that we saw to solve the continuous super race. So the third one, it's a hard one. It's sliding window maximum. So let's see how it goes. Um, Please, if you like it, the video or the content, uh, like the like the video, share, subscribe, leave a comment, and all of that. And let's get started. So sliding window maximum. You are given an array of integers, nums. There is a sliding window of size k, which is moving from the very left of the array to the very right. You can only see the k numbers in the window each time the sliding window moves right by one position. Return the max sliding window. So 1, 3, minus 1, minus 3, 5, 3, 6, 7, k3. The output 3, 3, 5, 5, 6, 7. Okay. So we have 1, 3, minus 1. Then we have 3 minus 1, 3, minus 3. Okay, so then we store that in an array and return that, right? Okay, so the constraints, the length of nums can be 1 to 10 powered by 5, and the numbers can be minus 10 powered by 4, and 10 powered by 4, right? Okay, and k, it's between 1 and the nums of length. Okay, so k, it's always uh, less or equal than the length of the array, right? Okay, so the first solution is the simplest one, is the brute force, right? We can always have the window and get the value, and then we can just move to the next, get find the maximum value, move to the next, find the maximum value, move, find. Probably this will not solve the issue, but let's start implementing this one. I think this is the safest one. Since it's a hard challenge, I think it will not be enough, but let's see. So first off, we need to define the right. And the right will be k, right, minus 1. So, and then while right is less than nums dot count, then we iterate the first iteration. Let's get the response then. Our response, that would be an array of integers. Um, then we're going to return the response, and yeah, so now we can just we're going to iterate through that, and yeah, we need to define the left as well, right? And this has to be var because we're going to change that. The left we're going to be you should start at 0. Okay, so then we have the first array. We just have to iterate through this array. So for um, index, right? Mm, L, L into R. Okay, then what? We have I have to find what? The maximum value, right? Maximum value. That is going to be so L plus 1, right? Maximum value is going to be nums L. And then here we um, can just put like that equals to max between nums y and maximum value. So then we iterate through the entire subarray like this, get the maximum value, and then we just append the response to the response. It's just one dot. We just append the maximum value, and then we just increase the right and the left. This is the simplest approach. So let's run. Let's see how it goes. Okay, what's going on here? Okay, we need to check first the guard, right? So guard, if let me just see one thing. Can be one. So guard nums dot count is higher than 1, right? Else return essentially nums, right? Okay, that solves the test cases, but it will not probably not solve all the cases, but let's submit and see how it goes. Okay. 1 minus 1. Why is it? Okay, yeah, for k equals to 1, let me just see the description again. K, yeah, k can be 1. for k equals to 1, we can just return nums as well, right? So we can probably do like that. Sorry, guys. Yeah. So yeah, let's submit again and see how it goes. Okay, it passed 47, but 5 left, right? Okay, so for this one, the time limit exceed. Let's use this test case and run. Yeah, okay, so it's passing here, but it's not passing if I try all the submissions. Okay, so what else we can do here? Okay, let's go to the description. We probably need to use some other structure, right? In the longest substring, we could find a stack to get the latest minimum, right? So here we can probably find another structure that can get the maximum one. So for this one, for example, we have 3, that is the maximum one. Then when we move to the next one, 3 is still the maximum. So we just, it's just um, getting a new value and removing the old one. Then we get a new value, then remove the old one. Then we get a new value, remove the old one. Until the end, right? So for these cases, we might actually use a stack as well, maybe. Let's think about it. So if we consider this example, if we have a stack for this one, then we have in the stack, let's let's try like that. So we have this, right? So for the first iteration, it will be like that, and the stack will be 3 because the maximum one. Then in the next one, it will be like that. Then it will be 3 again, right? So we can add 3. Then the next one, it has 3. 3, then we need to add 5. But how we are going to find out? I mean, let's continue for all of these cases and then we can just think about it. So here is 5 again. Then here it is 6. And here is 7. Okay, so this would be the answer. So when we go from here to the next one, we are just moving out, right? So then we just remove the first and put the third, put the -3. So we can just check the stack. So if the next one -3 it's higher, then uh, then we can just update, right? If it's not, then we just repeat, right? Like that. It's higher, we just update. It's not, if it's not in this case. But then again, here's 5, right? But here, if we had like 2 instead of 5, it would be 3, 3, 2. So what about it? Hmm. So these verifications we need to do already. So we have to work around this thing, right? This thing right here is n is squared, right? Or any n times k, right? Because it needs to iterate through k in the worst case scenario. Okay, so let's comment this thing out and try a better solution. Um, let's see how it goes. So, okay, so first off, we have like we need to iterate at least in the first, right, to check the maximum value. Or what else we can do here? Because we need that, right? We need to find the maximum one here. Maybe we can have a stack like in the longest substring where we have a stack and we are going to iterate one item by one, and then we just put the longest until that, or maybe the previous value. Okay, so maybe we can do like that. So let's try this. So for um, right, in 0 until nums.count. So then we don't need this anymore. So for 0 to count, so then we can start from 0 and then we just increase, right? So let's have a stack. So var stack. So mm, what we can do, I think this stack is not enough. Okay, this one. Okay, let's think about this stack. So let's start with the this one. So then what? So we have the first item that will be just one, right? Then we have the second item that would be three, and then we can have one, three. Yeah, but for this one, you can remove the first one, right? On the QE. Okay. So first off, it will be like that. Then we're going to have one, three, and we can remove the three. Then we're going to have one, three, minus one. Then we can keep the three, then we can keep the three. Then what? Then we're going to move three, minus one, minus three, because it moves right. The left moved as well. So here we must keep the 3 from that, and then we must keep, because now we have a full window, right? And then we must keep the 3 and add the 3 here. And then what? Then it's minus 1, minus 3, 5. Okay, so just lose the 1 and add the -3. So here we lose the 3. So yeah, what we can check is if this new value is upper than what we had, it will be added. But if the latest upper value is going out, then we have to check again, right? Okay, guys, so maybe we can have just maximum value and then we iterate through the window if we find the maximum value going out of the window. This might help, right? So we don't need a stack, so maybe we can just have maximum value, right? So the maximum value will be uh, nums 0 for now. And so then we don't need to start from the 0, right? We can start from the first one, from the second position, I mean. And so yeah, for the second one, if R is lower than K, we're going to do something. If it's not, we're going to do something else, right? So if it's lower than K, we are going to just check the maximum value, right? So the maximum value is going to be the maximum value is going to be max between maximum value and nums r, right? So for example, k is 3, so until r is different than key, so we're going to 1, 3 minus 1, then we're going to the else, right? So here let's just check if the next one, like r plus 1, is going to be equals to key. If so, we are going to append the maximum value to the response. Um, okay, so else. Now we have to, for this thing, we have to move the L one index to the right. So then so then we need to check first. We need to check the L here, right? If it's equal to max value, it's going to do something. If it's not, we're going to do something else. So if it's not the max value that it's going out of the window, we can just um, like this would be plus equal to 1, right? So none is equals to max value. So if it's equal, like in this case, it's for this, right? Then we need to find, right, the maximum value again. Then I need to find the maximum value again. If it's not, we need to append the maximum value. If it's not the maximum value, we just need to check the maximum value between nums of bar and maximum value, right? Yeah, I think that's it. Wrong answer. What? What? Quite having a wrong answer for this one. Ah, okay. Yeah, we need to re-update this, right? Okay, it's working. Let's submit that. Okay, guys, we did it. Let me remove these comments. Um, Please, guys, let me know if you find some other solution, maybe a better approach for this. And yeah, uh, thank you, guys. I see you in the next video. Bye bye.